What is up, guys? Fahir here from AwesomeDudes.com. In the previous video, we created our level, and what are we going to do now is make the camera follow the player, because if we start playing the game now, eventually the player will go out of bounds and we will not see him because the camera is not following the player. So in order to do that, in the scripts folder, right click and create a new folder. This one is going to be camera scripts. And inside of this folder, we are going to create our C# script, which is going to be camera follow, which is going to follow the player. Now, before I attach this script to the camera, select the camera and add a box collider 2D on it. Now, I'm going to use the box collider 2D in order to determine the bounds of the camera where the player can move and not. If I also take and remove the background, you see where the box collider is when I select the camera. I don't want it to be this small. Instead, for the X, I'm going to say 17.77, something like that. Maybe 15 for the Y. Yeah, I think this will do. But when I hit the play button now, we will see that, well, we don't see the player. The reason for it is because the player, I think, where is he? Where is the player, man? Yeah, he fell down. He fell down because the collider threw him off. Because this collider for the camera is not a trigger, which means that he can collide with the player and then, well, he simply threw him off the screen. If I set it to be his trigger, now everything will be okay. So now the player can walk safely in the collider. So take the camera now, and I'm going to put back the background and attach the camera follow script, and bam, here we are. Double click it, open it in Mount & Develop, and let us get to work. First of all, you know what I'm gonna do. I don't even have to say it, just watch me do it. And now we need a couple of variables. So the first variable that we need is gonna be a public float reset speed. Now this speed is going to determine how fast the camera goes back to the player. 0.5. By default, we set it to be public, which means we can edit this anytime we want in the inspector panel. Now we are also gonna create a public float camera speed, which is self-explanatory. It's the speed of the camera, by default 0.3. We also need bounce, which is gonna be camera bounce like this. We're also going to create a private transform, which is going to be the target, or actually the player, because we're going to use the player's transform in order to follow the player, because transform can give us the position where the player currently is. The next thing that we need is going to be a private float offset Z. We also need a private vector 3, which is going to be our last target position like this, and a private vector 3, which is going to be the current velocity. This is going to be the velocity or the speed of our camera. We will see how we're going to use that. And we need a private bool, not provet, but it's a private bool, follows player. So we're going to say here follows player like this. So now what are we going to do? First of all, in the awake function, so void awake, we are simply gonna make sure that the size of the bounds of the box collider, that they are correct. So we are gonna say here box collider 2D, which we are gonna say my COL, or my collider, short for collider, my col, short for collider, is equal to get component box collider 2D like this. We're also gonna take my collider dot size, and we're gonna set that to be equal to new vector 2, and we're gonna type here camera dot main dot aspect ratio, which is the aspect ratio width divided by height. We're gonna multiply that by 2, and we are gonna multiply that with the camera dot main dot orthographic size, and here I'm gonna say 15 for the Y. Now this was for the X. This is for the X-axis. This way we're gonna determine the size of our collider in respect to the camera. Now camera.main, we already used this right here inside of the scale background script, and I did not explain it, I forgot, so excuse me, or sorry for that. But camera.main refers to the main camera. The main camera in the game is the one that has a tag So it has a tag, main camera, as you see right here. This is by default. The tag is created by Unity. Every time you create a new scene, you will have automatically a camera inside of that scene, and that camera will be tagged with the main camera tag. And here we see, well, the main camera is tagged with that tag. Now, camera.main, and if I hover over here, it says the first enabled camera tagged main camera. So it will search for that camera. And orthographic size is the size that we talked about, and I have explained that. So main aspect multiplied by 2, multiplied with the orthographic size. This is for the X size of the box collider. And now we're going to take the camera bounce. So here they are. We're going to say that this is equal to my collider.size. This is for the, well, bounce of the camera. Now for the start function, here we're going to get the target. So target is going to be equal to game object, find game object with the tag, and we're going to say my tags.player tag. And we need to say dot transform because we are trying to get the transform from the player. Game object, find game object with tag. That means that it will go in the scene, it will search for a game object that has this player tag, and it will get and return that game object. Let me just see what here we have. So camera bounce is not equal to collider.size. Actually, it's not the size, it's the bounce. So excuse me for that. So camera bounce is equal to my collider.bounce and not the camera size. Anyways, going back to what we are doing here, this will go in the scene and it will search for a game object that has this tag that we have specified here. We know in the tags that the player tag is this one right here, and we know that we have tagged the player with that tag. So if I select the player, here he is, and this is his tag. So again, this right here will go in the scene, get us the game object with this tag, and we can say dot transform to get his transform. We can say that dot get component to get some component from that game object, so on and so forth. But this is how you can get a game object from the scene. The next thing is that we're going to say last target position is going to equal to target position. So we're going to store the last position of the player by using target position, simply like that. And next we're going to say offset z is going to be equal to, in parentheses, transform dot position dot z, or actually transform dot position minus the target position, and here we're going to say dot z. This will get us the current position of the game object which carries this script, which is the camera, and we're going to subtract from that position the position of the player, and we're simply going to say dot z to get the offset z for our camera. And here we're going to say follow player is equal to true, because now we are going to start following the player. In the fixed update, and we talked about what is fixed update, it will be called on every time interval. And I said that you can create, or that you can control that by going here in edit, then going into project settings and going into time, and you will see here fixed time step, it's 0.02, which means that every 0.02 of a second, this right here will be called. It is, well, it's not frame dependent. So update is called every frame. If we have 30 frames in a second, update is called 30 times. If we have 1,000,000 frames in a second, update will be called millions times. So fixed update is not like that. In general, fixed update by default value will be called like 2 or 3, 4 frames every 2 or 3, 4 frames. 2 or 3, 4. 3, 4 frames every second. So if we have 60 frames and it will be called every third frame, that means it will be called 20 times in a second. So in the fixed update, first we are going to check if follows player, if we can actually follow the player. What we are going to do, we are going to get a vector 3, which we're going to call ahead target POS, ahead target position with capital T. Let me just go here and correct that. Is going to be equal to target position plus vector 3 dot forward, and we're going to multiply that with the offset z. This is going to be the ahead position of our player, which means the position that is ahead of our player. And we're going to test here if ahead position dot x is greater or equal to transform dot position dot x, which means we are testing if this position is greater than the camera's current x position. So if the x position of this ahead position is greater or equal to the current X position of the camera. We are going to say here vector 3 new camera position. So vector 3 new camera position is going to be equal to vector 3 dot smooth dump. And we are going to do that from transform dot position towards the ahead position or ahead target position using a reference. And here we're going to say current velocity and using the smooth time camera speed. Now, what are we doing here? This smooth dump will gradually move this vector, which is this one, new camera position, from this position towards this position by using the current velocity. Now, this current velocity, we actually don't need it, but this smooth dump it takes 4 parameters as arguments, so we need to add it here. But the important thing is to pay attention to these two and this one. So it will essentially move from this position towards this position using this speed. Now this current velocity, as I said, we need to add it here. This value will be changed by the movement of this smooth dump. So as it moves from this position to this, it will change the value here. And we are passing here ref. What is this ref keyword? Well, the ref method parameter keyword on a method parameter causes a method to refer to the same variable that was passed into that method. We talked about passing variables by value and passing them by reference. Now here, by using the reference, it means it will, well, refer to this current velocity to this variable. So it will refer to this variable. It will not refer to the value of it, but it will refer to the reference of it. So it will change the reference, meaning it will change this value right here. So this value right here will be changed. Now again, just pay attention to these two and this one right here. It will move from this position smoothly towards this position in this timely manner. As I said, we need to add this one because if we remove it, Unity will complain because smooth dump takes 4 arguments. And now what we can do is we can say transform position, which is the current position of the camera, is equal to new vector 3. And here we're simply going to say transform or new camera, excuse me. So new camera POS or position dot X transform dot position dot Y, which is our current position Y. We don't need to change the Y position. And new camera position Z for the Z axis. And the last target position, so last target position finally is equal to the target dot position right here. This is just so that we can know where the player currently is. Now again, what did we do here? We took a box collider, which we are going to use for our bounds, and we resized his size by using camera main and the aspect multiplied by 2 multiplied with the camera's orthographic size. For the Y, I'm using 15. So now that we have that, we are setting the camera's bounds to that value. In the start, we're getting a reference to the player by using game object, find game object with the tag in the scene. The last target position, we are storing that right here. We're calculating the offset from the current position of the camera and the current position of the player. And we're saying the follows player is true. If we can follow the player, if that is true, vector 3 ahead position is going to be equal to target position, which is the player's position, plus vector 3 forward multiplied with the offset Z. So now, ahead position, if the X of the ahead position is greater or equal to the current position's X of the camera, we need to move the camera. Meaning, new camera here will be smooth dump, which means it will move smoothly from the current position of the camera towards the new position here, which is the ahead position, in this timely manner. And I've explained that we can ignore safely this parameter, these 3 parameters right here. So this one and these 2 are the ones that are important. So now that we have the new camera position, the transform position, which is our current position of the camera, is now equal to new vector 3 passing the new camera X position. Our Y position can stay the same because we don't want to follow the player on his Y position. And new camera position Z. And we need to record the last position of the target. So we're simply gonna, well, save it right here. And voila, we are good to go. If I go back here in Unity and test it out. So if I go here, if I hit the play button, notice what's gonna happen. So now the camera will not follow the player if we go here, but it will follow the player if we go here, because the camera will not follow the player if the X position is not greater or equal to the camera's position. If the X position of this ahead target position is greater or equal to the camera's X position, then the camera will start following the player. And notice how the camera is following the player. You see? So now the camera follows the player very nicely. And let me just go and jump over here. Oh yeah, we need to take the water and put the water on the sorting layer 2 so that it is visible. So let me just go back and hopefully we will see our water. So go here, jumpy, jumpy. Look how happy our player is. So yeah, we now see the water. We see the coins. We can jump over the water. Did I add a box collider? No, I did not. Now you saw that the player got stuck. You see here? The player got stuck for some reason. Now I'm not sure what this reason is, why the player is getting stuck here. But how can we fix this is that we can go in our project and assets and right click, create a new folder, which I'm going to call physics materials. And inside of this one, I'm going to right click and create a new physics material. So physics material 2D. And I'm going to take this one and I'm going to name it no friction. So no friction. And for the friction here, I am going to simply say 0. And now I'm going to take all of our grounds. So select all of these grounds up to ground 86 and drag and drop no friction physics material into their box collider. You will see here material and you have an empty field. You can drag and drop that no friction physics material so that now when I run the game, you will see that the player is not being stuck between these colliders. Now, if you see him being stuck somewhere, maybe the arrangement is not that great. Maybe the platforms are not positioned correctly on the y-axis. So some is a little bit higher than the other. So the player gets stuck in that way. So you can rearrange that. But the point here is if you use this, well, friction or no friction physics material, everything will be okay. And I see that we need to fix this bush with his order in layer. We will do that later on. Do not worry about that. So actually simply select the bush right here and order in layer. For the bush, I am going to say 1. And that is that. For the trees, I set it to anyways. Either change it to 2 or 1 depending on how the effect is being applied to that game object. Anyways, my point here is that the camera is now following the player. You see when we go, the camera is following the player. When we go backwards, it will not follow him. Because, as I already said, because of this here, we're only going to follow the player if the ahead position is greater or equal to the transform's position X, which is the camera's X position. And we explained all of these lines of code and how are we following the player. So, Fahir here from AwesomeTuts.com. I will see you guys in the next video.